Back in 2009, my colleagues published the precise physics of a dust bowl. Not a guess, not a hypothesis, a peer-reviewed, model-validated, causal blueprint for catastrophe. Specific thermal anomalies in the ocean, land conditions, and feedback loops that synthesized to recreate the event that killed 7,000 people, ravaged 100 million acres of soil, and plunged the sky into total solar eclipse at noon during the 30s. Today, in April 2026, those variables have aligned over the plains. The drought is in year 6. Our thermal sensors show a perfect match. Our terrestrial defences have been dismantled. Why is the government ignoring the telemetry? Stay with me. The data suggests something far more chilling than the storms themselves. If this data alarms you, subscribe to the Sky Lab. We are monitoring this signal in real time as it unfolds, and we will keep analysing every spectral reading as things progress. New data points, new drought metrics. You need to be here for what our models predict. Let us review the findings. Part 1. The conclusion no government agency dares to state. On March 15, 2026, the sky over Lubbock, Texas, mimicked the spectrum of a dying star. Not metaphorically, in terms of literal luminosity. A wall of particles so dense that our atmospheric sensors essentially suffered a system failure, unable to quantify the sheer mass of the readings. Standard terrestrial indices peak at 500. That value represents an environment so hostile that it is classified as biologically hazardous across the board. Seal all hatches. Do not vent outside air. The sensors in Lubbock hit 1,400. The hardware worked fine. The environment had simply moved into a range beyond our scale, a regime of chaos the engineers never anticipated we would ever encounter. Process that data for a moment. We designed the instruments, but reality broke the scale. That is not just a data point, it is a planetary warning. That week, the Amarillo station issued a haboob warning. If that term sounds alien to you, it should. It belongs in a different climate entirely. A haboob is a phenomenon characteristic of extreme desert landscapes. Think the Sahara, the Arabian Desert, or the Martian plains. It occurs when collapsing storm cells accelerate air across desiccated terrain, creating a kinetic wall of grit capable of displacing heavy vehicles and blinding sensors. That terminology should never appear in our models for the Texas Panhandle. Yet there it was, official telemetry confirming that standard meteorological language had failed. My colleagues realized the old labels could no longer describe this planetary shift. That same event, or perhaps a subsequent surge in the sequence, because these waves were hitting like rhythmic orbital pulses, triggered a massive highway collision as visual range hit absolute zero. Not obscured, total darkness. The kind of vacuum where you do not see the obstacle until the moment of impact. If you and I examined the NACE of satellite imagery from that week, the spectral data would have looked deeply alarming to any expert in remote sensing. Massive plumes of grit, clearly visible from orbit, were migrating eastward across the entire continent, originating from a locus in the southern high plains. It is the exact same coordinate grid that triggered the 1935 disaster. Here is the anomaly. Not just the magnitude, but the intellectual inconsistency of it all. It defies standard observation. Every parameter we measured in 2026, drought cycles, surface exposure, thermal gradients in the ocean, it was all there. The circulation patterns and failing land use buffers were all mapped out in the literature years ago. It is the textbook, peer-reviewed signature of a looming dust bowl. Not a regional drought or a seasonal event, a true dust bowl, a total system collapse. The team that cracked the code published in the Academy Proceedings in 2009. That was 16 years ago. The physics are established, the warning is ancient. So, here is the core inquiry we must address, and I will state it with scientific clarity before we proceed, because the rest of our analysis hinges on this. If we have known for 16 years exactly what triggers this state, not theoretically, but precisely, using a peer-reviewed model, validated against a century of historical data, and every catastrophic variable is now active and measurable right in our sensor's view. Why is the federal bureaucracy refusing to acknowledge the alarming data on American soil right now? That is the primary anomaly in our entire investigation. Not the atmospheric conditions, but the radio silence from the top. Let me synthesize the full picture, because the data is currently scattered across disparate agencies and unconnected news cycles. The true threat only emerges when you overlay all these data sets. We will begin with the science. Not just the conditions, but the breakthrough that allowed us to decode this crisis. Before 2009, the precise physics of the 1930s were a mystery. It was a recorded disaster, but we lacked a definitive causal mechanism. Our telemetry shows a drought that has persisted for 6 consecutive years across the Texas and Oklahoma territories. It has already surpassed the initial phase of the 30s drought that led to the Black Sunday event. Ocean thermal patterns now align with the trigger for the original disaster, with a precision that should worry any objective observer. We have watched our soil protection infrastructure be methodically dismantled over the last 2 decades without any public debate, eliminating the buffers installed post-1935 to stop a recurrence. Now, we face dust storms so intense we are forced to use terminology usually reserved for the Sahara. The formula has reactivated. Every variable is now in place. Somewhere, an official who sees this data is choosing to remain silent. You and I are going to find out why. Before we go further, you and I need to analyze the data. If you don't grasp the breakthrough from 2009, our current reality just looks like a fluke. Once the mechanism is clear, it looks like a warning. Part 2. The 2009 discovery that rewrote the history books. For decades, we debated the primary drivers of the Dust Bowl. It is odd, really, because we have a mountain of evidence from that era. The archives are full of photos, accounts, federal records, and weather data reaching all the way back to the early 1900s. The damage was never the mystery. We all saw the destruction. The real puzzle was the underlying atmospheric mechanism. We couldn't prove why it peaked then, why it became so intense, or, most importantly, if the models show it could happen again. Throughout the 20th century, the debate centered on 2 main variables: extreme drought versus aggressive farming techniques. Either it was a purely climatic anomaly, a brutal long-term drought that just happened to hit a heavily farmed landscape, or was it a land-use disaster, the result of overploughing that stripped away native grasses and left the soil vulnerable? The data supported both sides. The drought was undeniably severe, and the scale of the ploughing was massive. Yet neither variable alone could explain the terrifying scale or the decade-long duration of the collapse. If droughts were the only driver, previous dry spells before the ploughing began should have produced similar dust storms. They didn't. And if it was just overploughing, we would have seen dust bowls in other farmed regions that lacked drought conditions. But we did not see that feedback elsewhere. The 2 theories were locked in a stalemate, each pointing at the other. Drought explains the lack of moisture. Farming explains why there was no ground cover to hold the soil. But the catalyst, the exact amplification that turned a dry spell into a total ecological collapse, remained a scientific mystery. Then, in 2009, researchers Benjamin Cook, Ron Miller, and Richard Seeger published a landmark paper in the Academy of Sciences that fundamentally shifted how we view those events. Cook was working out of NASA's Goddard Institute. Miller and Seeger were based at the Earth Observatory at Columbia University. They ran complex climate simulations using computational models to isolate exactly which variables pushed the Dust Bowl to such extremes. The results settled the old debate, proving that both camps had been partially right, and both had missed the bigger picture. Today we are using general circulation models, the same computational systems you and I rely on for weather forecasting and climate projections. They began by feeding the model real sea surface temperatures from the 1930s, but without including any of the land degradation. Then, for the final trial, they factored the damaged landscape back into the simulation. The data was startling. revealing the distinct impact of each individual variable. Ocean temperatures alone, specifically a cold tropical Pacific and a warm North Atlantic, were enough to trigger a major drought across the Great Plains. The simulation confirmed that the ocean thermal state was a powerful driver for the regional drying. The atmospheric physics are actually quite straightforward once you see the data. A cold Pacific shifts the jet stream, pushing storms north and trapping a massive zone of sinking air over the southern plains. Sinking air kills rainfall. That is basic physics, and the model was spot on. But here is the critical part of their discovery. Ocean temperatures by themselves did not recreate the full intensity. Without land degradation, the model only showed a standard drought. It was not a dust bowl. The heat signatures were off, rainfall was too high, and the feedback loop was missing. A critical component was absent from the math, and the team knew exactly what it was. When they factored in the stripped landscape and the lost vegetation of the high plains, the entire simulation suddenly shifted. The temperatures finally matched the historical records. The rainfall deficits aligned perfectly with what was actually measured in the 1930s. The feedback loop emerged. Bare soil radiated massive heat, and dust aerosols began warping the entire local energy balance. The atmosphere reacted to the dead land by reinforcing the drought, preventing the system from recovering as it normally would. Cook's team proved that the Dust Bowl was not just a simple case of bad luck or poor timing. It was a total system failure, climate forces hitting a landscape that we had already stripped of its natural resilience. This created an interaction that neither factor could have caused alone. The dust was not just a symptom of the drying. The dust was an active participant, making the drought deeper and longer. That was the crucial insight we had missed. By 2008, Cook was already quantifying the radiative forcing of the dust, how it physically manipulated solar energy. He tracked how suspended particles in our atmosphere absorb and reflect the sun's radiation in real time. This warped ground temperatures and atmospheric stability, killing off any chance of rain. Once airborne, that dust was doing climate work. It was actively modifying the system that created it. Essentially, the Dust Bowl developed its own immune system against recovery. Now you and I must face the implications of this in 2026. The Dust Bowl is not some historical anomaly. It is a blueprint. This isn't a fluke or a unique event. It is a reproducible state of an atmospheric system. Combine specific ocean temperatures with land surface degradation, and you get a dust bowl. That's the equation. If we can identify that equation in the historical data, you and I can recognize when the variables assemble again today. We can watch the recipe come together in real time, which is exactly what we can now do, and exactly what we see happening. The question is not whether we understand the mechanism. We do. The question is how we handle the fact that those mechanisms are running again. Part 3. The ocean configuration has reappeared. One specific number matters more than almost any other data point in this story. It's called the Oceanic NINO Index. NOAA maintains this index as its primary tool for monitoring the state of the tropical Pacific Ocean. Specifically, it tracks if sea surface temperatures in the central and eastern equatorial Pacific deviate from the long-term average. Positive values signal El Niño conditions. That means a warmer tropical Pacific and wetter winters for the southern United States. Negative values indicate La Niña conditions. A cooler tropical Pacific leads to drier winters across the southern United States. The magnitude of the departure from the average tells us exactly how strong the forcing is. In the winter of 2025 to 2026, the index hit approximately negative 0.55 degrees Celsius, a weak state. By early spring 2026, that number migrated toward negative 0.16, approaching what NOAA classifies as neutral territory. To a casual observer, that transition from weak La Niña to near neutral might look like the situation is improving. If La Niña causes drought and is weakening, surely the drought should weaken too. That's a reasonable assumption based on the data, but unfortunately, it is also incomplete. Here is why. The Cook, Miller and Seeger research didn't identify a strong sustained La Niña as the trigger for the Dust Bowl. It identified a specific pairing, a cool tropical Pacific combined with an unusually warm North Atlantic. That specific pairing, not La Niña alone, is what atmospheric models link to the drought patterns over the southern plains. That distinction matters in 2026 because the second half of that pairing, the warm North Atlantic, is not weakening at all. By multiple measures, it is at record levels. The North Atlantic has been running anomalously warm for an extended period. The specific mechanism by which a warm North Atlantic reinforces drought is distinct from the Pacific mechanism, but they work in the same direction. While Pacific cooling shifts the jet stream northward and creates air subsidence over the plains, Atlantic warming alters the temperature gradient that drives moisture transport from the Gulf of Mexico northward into the continent. In certain warm Atlantic configurations, it can actually suppress the northward flow of Gulf moisture that would otherwise provide vital rainfall to the plain states. These two basins create an atmospheric pincer. The Pacific pushes the storm track away, while the Atlantic reduces the moisture source. This exact configuration, a cool or neutral Pacific and warm Atlantic, is what the 2009 paper identified as the oceanic fingerprint. And this is not a rare configuration. Looking across the instrumental record back to roughly 1880, researchers have identified between 8 and 12 occurrences of similar pairings over approximately 145 years of data. That means it happens roughly once every 12 to 18 years on average. It's not unusual. What is unusual is the combination with a land surface that has been simultaneously degraded. Here is the critical point from the Cook research. The ocean configuration creates drought, but it doesn't create a dust bowl alone. The drought must find degraded land to work with. In years when this same ocean configuration occurred, but the land was under protective cover, you simply got a standard drought. You got dry years and agricultural stress, but not the self-reinforcing feedback loop that produces catastrophic and sustained dust mobilization. The ocean sets the table. The land determines if the meal becomes a disaster. There is a question you and I should really consider here. Scientists are actively debating it, rather than presenting it as a settled fact. The North Atlantic warming trend is a phenomenon most researchers attribute, at least partially, to the accumulation of greenhouse gases in the atmosphere. If that trend continues, and there is no physical reason to expect a reversal, does it mean this particular ocean configuration becomes more persistent, more likely to recur, and more likely to stay in place for much longer now? We do not have a definitive answer to that question yet. What we do have is the observation that the configuration is present. It matches the documented trigger for the original Dust Bowl, and it is now combining with drought conditions that have persisted for 6 consecutive years. The ocean started this sequence, but the ocean is only half the story. The other half is right under our feet. You and I missed how it was changing until the dust finally started moving. Part 4. The drought that quietly crossed the line. The United States Drought Monitor is a joint product of the National Drought Mitigation Center, NOAA, and the USDA. From our orbital sensors, we generate weekly maps tracking drought across the states. The scale starts at abnormally dry, climbing through moderate and severe levels. Then we reach extreme and exceptional, the most intense category. These signatures represent damage so deep that recovery takes years, even once the rains finally return to normal levels. By early April 2026, our data showed nearly 89% of Texas suffering. A massive portion of the state has already entered that critical, severe to exceptional range. Oklahoma was worse, 99% drought coverage, almost the entire state. The epicenter of this planetary scar is centered exactly where the historic Dust Bowl once tore the land apart. The Texas Panhandle, southwestern Oklahoma, southeastern Colorado, and the edges of Kansas and New Mexico are burning. But looking at the area isn't enough. You and I need to look at the duration. This dry spell across the southern high plains has now persisted for 6 consecutive years. 6 years! Imagine that. The drought before Black Sunday, that catastrophic 1935 dust event, only built up for 3 or 4 years. We have already watched this one surpass that timeline. This current cycle is already longer than the early phase of the 1930s disaster. We have moved past the point of simple bad weather. This isn't something a normal season can fix. 6 years of drought isn't just about missing rain. It is about a compounding deficit in the soil moisture that one wet spring simply cannot replenish. Dying plants, empty groundwater, and a shattered surface crust make it impossible for the earth to breathe or absorb. The land loses its shield against the wind. We need to understand this clearly. The link between drought duration and land vulnerability is not linear. It is exponential. In the first year of drought, the grasses go dormant. They wait. Annual plants fail to grow. By the second year, the perennials thin out. Root systems weaken. The very structure of the soil begins to degrade. Year 3 brings massive die-offs. The internal channels that once allowed water to soak in simply collapse and vanish. The earth develops a hardened, sealed skin. Rain just bounces off instead of soaking in. Even when a storm hits, the water is wasted. By year 6, we are scanning a fundamentally broken system. This is not just dry soil, it is dead. The land is degraded. That distinction determines exactly what happens the moment the great winds begin to howl. From our view, the expansion pattern is alarming. Eastern Colorado was shielded for a while, but that changed rapidly. We saw rapid degradation there in April 2026. It dropped to full drought category in just 1 week. This kind of collapse isn't just a shift in weather statistics. It is a massive system on the move. The drought is expanding its footprint, echoing the terrifying patterns of the 1930s. Now, add wildfires to this dying soil. The situation is escalating. Over 1 million acres burned in early 2026 alone. In this context, fire isn't just a disaster, it is a planetary reset. It prepares the ground for total dust mobilization. The fire strips away every last bit of protection. It incinerates the organic layer that holds the earth together. The very chemistry of the soil is being altered forever. When the wind arrives, it finds a naked world. No moisture, no roots, no cover. Just rising, black dust. Agricultural losses have already reached $23.6 billion. The cost of this crisis is staggering. That number is massive, but it's more than just an economic data point. It tells us that our planetary systems are nearing a total breaking point. These losses mean the infrastructure of the southern plains has been under extreme, sustained stress for over half a decade. It means the people below are exhausting every reserve they have. Financial reserves, soil reserves, groundwater reserves, spent just to survive another day. The system is no longer in equilibrium. It is in managed decline. Even the tools preventing a total collapse are failing. This brings us back to the central question of our investigation. Ocean configurations triggered these drought conditions, and the heat has systematically decimated the soil below. But whether this becomes a new dust bowl depends on one final, terrifying variable: the land itself. In 2026, the state of the land is far worse than anyone realizes. Part 5. The missing ingredient. Decades ago, over 5 million acres of native sod were systematically destroyed. That short grass prairie had deep roots, 6 feet down, evolved over millennia to survive the harshest planetary dry spells. These plants were built to go dormant, not die. But then came mechanized ploughing, fueled by greed and high prices. World War I made farming these plains incredibly profitable. Back then, the land still looked healthy and productive. Economically, there was no reason not to plough. But that native sod was more than just grass. You and I can see now that those roots were the only things holding the earth together. Soil aggregates that withstand kinetic energy, because their density and chemical bonding make them too massive for atmospheric transport. When you mechanically disrupt that native sod, you shatter those critical aggregates. you sever the biological root networks. You expose raw, individual particles once locked in a complex living matrix. You have not just cleared a biological community, you have shifted a stable geological surface into an active source for atmospheric aerosols. When the rains fail and the canopy dies, we see a naked, fragile landscape exposed to the wind. There is no buffer left at the surface interface. That was the history. Now, let us examine the telemetry. The Conservation Reserve Programme, or CRP, was launched in 1985 to stabilise these fragile planetary zones. It takes vulnerable farmland out of rotation and restores the native bioshielding required for local stability. From a systems perspective, it was a partial rollback of the 1920s disaster, only partial. We cannot replicate a century of evolution overnight, but we can maintain a vital shield on vulnerable acres. At its peak in 2007, the programme protected approximately 36.8 million acres of our soil. By 2026, our planetary defence had dropped by 11 million acres. 11 million. For context, the total acreage ploughed before the original Dust Bowl was 5.2 million acres. We have stripped away twice the protection that failed us back then. We need to be mathematically precise here. This is not a perfect mirror of the 1920s. The spatial data shows these losses are widespread. Not every acre is at critical risk, but the planetary trend is moving in the same direction. Stable, protected ground is being forced back into production. The catalyst for this decline is purely economic. Federal rental payments for this land have lost their gravitational pull compared to the surging value of crops. When the math favours exploitation over conservation, the data shows farmers will always choose to plant. This is not a moral lapse, but a systemic response to a decaying incentive structure. Then, consider the shelter belts. Following the Great Depression, the government engineered a massive biological array known as the Great Plains Shelter Belt. This was a planetary windbreak system stretching from Canada to Texas, designed to disrupt surface wind velocity. 220 million trees were deployed between 1935 and 1942. These were not decorative. They were functional planetary infrastructure. The physics behind them is remarkably simple. Trees create atmospheric drag, slashing wind speeds in a protected zone 10 times the height of the canopy. Lower wind speed directly reduces the soil's erosive potential. The atmosphere's ability to lift and carry soil particles drops dramatically as wind speed decreases, because this physical relationship is not linear. A slight drop in wind speed kills the erosion curve, yet our sensors show a grim trend since the 90s. From orbit, we see shelter belts vanishing. The same mechanical efficiency that gutted the CRP is driving this removal. Industrial farming and GPS guidance work best on flat, empty plains. To a machine, trees are just obstacles. Clearing them improves short-term efficiency, but it deletes the atmospheric defense we built decades ago. Multiple research groups have tracked this decline, and their telemetry confirms a consistent, alarming conclusion. The protective shield installed after the 1930s disaster is being methodically dismantled. Factor in federal crop insurance, and the structural integrity of our landscape looks even more compromised. Subsidized insurance pays out for losses from drought and erosion. While stabilizing, the feedback loop is dangerous. It creates a safety net, but we must analyze the behavior it encourages on the ground. A farmer who risks planting on fragile, erosion-prone land gets compensated when the system fails. But a farmer who keeps that land stable under grass receives a smaller rental check. The rational move is to exploit the margin, risk the soil, and let insurance cover the inevitable crash. We are subsidizing the exact land use patterns that trigger disasters, while underfunding the shields designed to stop them. We have the oceanic thermal configuration. We have a 6-year drought cycle. We have a naked, stressed landscape losing its grip on the earth. The degradation identified as the primary amplifier for turning drought into a catastrophe is currently active. When these variables align, the math changes. you and I are watching the system enter a self-sustaining spiral. Part 6. Dust is not just a symptom. In our analysis, it is a formidable geological force. From orbit, we saw the hydration vanish and the soil crumble. The plumes were the visible signal of a world breaking. That satellite image is accurate, but it misses a hidden variable that is critically important to our models. You and I must understand why the Dust Bowl persisted, because our current telemetry shows the same potential for disaster. Dust isn't just a passive byproduct. Once it hits a massive scale, it drives the climate system itself, a feedback loop that doesn't just react to drought, but sustains it. Let's examine the orbital physics. Those dust aerosols manipulate solar radiation in two distinct, dangerous ways. Fine particles deflect sunlight back into the void, cooling the surface directly beneath the thickest part of the plume. But coarser grains soak up that radiation, turning it into heat that cooks the atmospheric layer where they linger. The net result at the surface is a massive drop in solar energy. Less sunlight actually reaches the ground. That might sound helpful for crops, but the atmospheric physics differ. Warming the air while cooling the soil creates a lethal stability. In a stabilized atmosphere, convection, the vertical engine that builds rain clouds, is completely suppressed. Zero convection means zero rain, and no rain means the drought only tightens its grip. Drought exposes more soil. That soil becomes more dust. The circuit closes, and the system begins to accelerate toward catastrophe. Back in 2008, researchers were among the first to quantify how this feedback drove the historic Dust Bowl. The data revealed that dust wasn't just a side effect, it was a radiative amplifier that kept the sky dry for years. From a planetary perspective, the Dust Bowl wasn't just a dry spell that happened to be dusty. It was a drought that triggered a feedback loop to sustain itself. It became, physically, a self-perpetuating engine. The exact magnitude of this feedback is one of the great unknowns in our current scientific picture. Different simulations provide various estimates for the 1930s, and we are still crunching the numbers to find the truth. But one thing is clear across every dataset. Dust isn't neutral. It's a robust mechanism for sustaining a drought. As you and I analyse the current situation, the implications from our sensors are sobering. The events of early 2026, like that extreme AQI in Lubbock, are more than just indicators of bad weather. Those massive haboob plumes visible from our satellites are signals that the feedback mechanism is now officially online. Every major dust event that crosses the threshold into continental transport is performing destructive atmospheric work. It is rewriting the regional energy budget and actively strangling the convection needed for rain. It makes the next dry day more likely than the last. The 2009 study didn't just describe a starting point. It explained how a dust bowl, once it begins, starts to feed itself. That mechanism is active now. We have to wonder how close we are to a threshold where we can no longer intervene. Transmission 7. The return of continental-scale particulate transport. On May 11, 1934, a dust storm from the northern plains swept across the entire continent. It carried 350 million tons of earth over 2,000 miles, eventually settling on ships in the Atlantic. It buried Washington and dimmed the sun over Chicago. New Yorkers found the planes on their windowsills the next morning. The storm was so massive, it fundamentally changed the political understanding of what was happening in the Great Plains. That was the moment it stopped being a local story and became a recognized national emergency. Moving dust on a continental scale requires specific variables, starting with a massive expanse of loose, fine-grained soil. You need surface winds hitting 12 to 15 miles per hour for fine particles, and even higher velocities to mobilize coarser material. You then need the atmospheric structure to lift those mobilized particles into the high-altitude wind currents. From there, the dust can be transported thousands of miles without ever touching the ground. And the source must be vast enough that the material isn't exhausted before it crosses the entire continent. In early 2026, NASA satellite imagery began showing dust transport events that signaled a significant shift. They haven't reached the 1934 scale yet, but the sensors are picking up the same fundamental pattern. Soil from the Texas and Oklahoma panhandle is being swept east, riding the atmospheric circulation across the country. The source is active, the wind is moving, the atmosphere is doing exactly what it was designed to do. Whether we are approaching another great continental storm is uncertain, and I must be objective about those data gaps. The planetary conditions required for a 1934 scale event are truly extreme. For a total catastrophe, we'd need to see significantly more bare soil than our sensors currently track. The atmospheric variables must align perfectly. Such anomalies were rare even during the 1930s Dust Bowl. They weren't seasonal. Look at what our satellite telemetry is showing. The source region is pulsing with activity we haven't witnessed in decades. These plumes are massive enough to track from low Earth orbit. They're suffocating air quality across major Texas metropolitan areas. They're spiking air quality readings well beyond every threshold the EPA index was ever calibrated to measure. The atmospheric corridor hauling plains material eastward is fully operational. We haven't hit 1934 levels yet, not quite. The data doesn't ask if it's possible, but rather what final variables must shift to make total collapse inevitable. Our 2009 models provide a chilling answer. Not much, just persistent drought and widening gaps in soil cover. One major wind event could do it. The system is hovering closer to that tipping point than since the 1950s. Every dust plume we track from space is a data point confirming the engine is running. The threat is real. The recipe for disaster is back, yet ignored. This isn't a simulation. It's an observable physical reality on our monitors. Part 8. When the AQI hits 1400, instruments fail. The EPA index was meant for public health, not extremes. The scale begins at 0 and peaks at hazardous once it crosses 300. It's a standard color-coded metric. It tops out at 500. At that level, our guidance is clear. Nobody should be outside. Period. Vulnerable groups must stay inside. If you have asthma or lung issues, this is a full-blown medical emergency. During the March 2026 storms, our sensors in Lubbock, Texas, recorded an AQI of nearly 1400. That isn't just a high reading, it's off the charts. It's in a realm the scale was never meant to quantify. When this scale was built, nobody planned for conditions that shattered the worst-case scenario by a factor of 3. The sensors worked, the telemetry was accurate. The failure was in our human framework, which simply couldn't comprehend the data. We assumed American air quality had a ceiling. Lubbock didn't just hit that ceiling, it tore right through it. From a medical perspective, the outlook is grim. We're seeing lethal concentrations of fine PM2.5 particulates. These microscopic particles bypass your defences, embedding deep in lung tissue and causing massive internal inflammation. Stay out there too long, and you'll trigger something we haven't seen since the 1930s. Dust pneumonia. Dust pneumonia wasn't a myth. It was a clinical nightmare, an acute illness born from breathing in pulverized earth. It led to fluid in the lungs and suffocated the victims. It was a killer, and it hunted children most of all. The Lubbock events of March 2026 aren't a perfect mirror of 1935, but they're terrifyingly close. Physically, they are the same beast. We are way beyond the point of mere academic debate now. Our planet is producing extremes that break our very models. That is the core signal in all this noise. Part 9. Why a haboob is a warning sign. Remember, the Weather Service is staffed by literal atmospheric scientists. Their work demands absolute precision. They don't just borrow terms from other climate zones for dramatic effect. When Amarillo issued a haboob warning for the plains, that word choice was a calculated, scientific alarm bell. It was a technical classification based on raw data and direct observation. Their instruments didn't lie. They were labeling the exact atmospheric phenomenon unfolding before their eyes. A haboob is an intense dust wall triggered by collapsing thunderstorms in bone-dried desert environments. The name comes from the Arabic for strong wind, moving from Sudan into our global meteorological lexicon. Now it's how we classify storms in the Sahara, the Arabian Peninsula, and the American Southwest. It's a staple of Arizona life. The Sonoran Desert regularly sends these massive dust walls through Phoenix. To get a haboob, you need a vertical wall, downdraft winds, and a massive supply of loose, fine-grained soil. When surface material is suddenly mobilized into a dense, suffocating wall of grit, you have a haboob. But Texas and Oklahoma aren't the Sonoran. They're certainly not the Sahara. Historically, these regions never possessed the environmental signatures required to generate haboob-class events. When the Amarillo office uses that word for farmland, it's a profound, chilling meteorological statement. Surface conditions on the plains have shifted enough that the weather patterns we see there now perfectly match desert environments. Our field forecasters, the ones closest to the atmosphere, have updated their language to reflect a grim physical reality. They're documenting a physical shift in our world that the public and politicians aren't ready to face yet. That disconnect between the orbital data you and I are seeing and the lack of ground-level response is the true mystery. My sensors confirm the system has shifted. The data is screaming, but is anyone in a position to act, actually listening? Part 10. Fire, dust and wind are merging into a singular kinetic force. One difference between the current situation and the 1930s, cited as a reason for cautious optimism, is the vegetation structure of the southern plains. The hypothesis goes roughly like this. A century ago, catastrophic ploughing stripped the native sod, replacing it with fragile annual crops across millions of acres of land. That left essentially no perennial root structure. Today, our scans show some residual vegetation clings to even the most degraded landscapes. It is far from a resilient ecosystem, but it provides some surface coverage. The scientific comparison holds, up to a point. What these models do not account for is wildfire. In early 2026 alone, more than 1,100,000 acres burned. The same physics driving the dust, extreme drought and high winds, fueled these infernos, consuming a massive accumulation of dead organic fuel. This was vegetation killed by drought, but still present on the surface. These thermal conditions were, by any historical measure, extraordinary. Here is why wildfire matters to our Dust Bowl inquiry. Fire erases the last defense that drought weakened but failed to kill. After a fire sweeps through, the organic surface layer, the dead plant litter and fungal networks, is essentially vaporized into ash and carbon. The biological glue that binds soil particles is gone. What remains is raw mineral soil, devoid of moisture and totally unprotected. Physically, it is indistinguishable from freshly ploughed ground. The wind does not know the difference between a field that was ploughed and a field scorched by flame last month. It only cares that it has found loose, unprotected material ready for atmospheric lift. It finds fine-grained particles sitting on the surface with nothing to hold them down. This feedback loop is a terrifying new departure. It runs faster. Fire exposes soil, dust alters the atmospheric energy budget, and the planetary balance begins to shift into chaos. Rainfall is suppressed, intensifying the drought and creating more fuel for the next burn. It is a self-sustaining cycle of ruin. This loop can accelerate in a way that the simple drought plus ploughing dynamic of the 1930s never could. This is because a fire can strip away the planet's protective skin in hours, whereas drought takes months to kill. And the 2026 fire season is hitting during the same drought that is already stressing the soil across the region. The oceanic patterns and land degradation are perfectly aligned. The recipe identified back in 2009 has been constructed. That model used variables from the 1930s. Our current system appears to have added an additional high-energy amplification pathway. The original data did not include this, raising an uncomfortable possibility. If the 1930s configuration was enough for Black Sunday, what happens when you add this new fire-dust feedback loop into the mix? What does that version of the storm produce? You and I are watching an experiment play out in real time, with no historical data points to guide our predictions. No federal agency is speaking plainly about this transition. It leads us to a part of the story deeper than climate. It involves something more systemic and harder to calculate. Part 11. The Ogallala Illusion. Why do the Texas Panhandle and the adjacent high plains remain intensive agricultural zones, despite the worst drought on record? It is not due to ecological resilience or natural rainfall. This planetary surface is not naturally meant to be well watered. The secret is the Ogallala Aquifer, a massive subterranean reservoir spanning nearly 174,000 square miles of the crust. It reaches from South Dakota down to Texas, holding more water than Lake Huron beneath the feet of the unsuspecting. Since the mid-20th century, high plains agriculture has survived by siphoning this fossil water to the surface in massive quantities. This life support system masks the surface catastrophe. The Ogallala is the only reason this region still appears stable to us. Visually, it looks more robust than the 1930s, but that is a mechanical trick played by industrial-scale irrigation systems. Satellite sensors detect green fields in the middle of a 6-year drought. That colour is bought with water from deep underground. We are pulling water from thousands of feet down and applying it to the surface. Everything looks productive, for now. What the orbital view hides is the depletion rate. This underground sea recharges at an agonizingly slow pace. It recharges by mere fractions of an inch annually, reflecting the low natural precipitation that reaches the depths of the aquifer. We are pumping this water 800% faster than the planet can replenish it. It is a total systems failure. Across the Texas Panhandle, this is no longer resource management. It is more like a mining operation for ancient water. Like any finite deposit, the levels are crushing. We are watching the epicenter of the Dust Bowl run out of time. Data suggests that in some sectors, there are fewer than 25 years of usable water remaining. The deadline is fast approaching. 25 years of irrigation left, at best. In certain high extraction zones, the sensors show we have already crossed the threshold. Wells that hit water at 60 feet in the 1950s now require drilling deeper than 300 feet today. I am tracking a drop in the water table that is making irrigation costs skyrocket. The economics are hitting a breaking point. This is critical for our model. The Ogallala Aquifer is not a cure for the baseline disaster. Think of it as a delay mechanism. It keeps farms alive on land that has already crossed the point of no return. Without this water, the land would have already turned into the barren wasteland we saw in the 1930s. But every delay has an expiration. Eventually, the Texas Panhandle will run out of aquifer water entirely. Maybe the wells run dry, or the electricity gets too expensive, or legal mandates finally shut down the pumps. Once that irrigation stops, the protective green cover will vanish, and when it goes, it happens with terrifying speed. This isn't a slow decay. The shift from green fields to bare dirt happens the second a farmer stops pumping. Back in the 1930s, our data shows they didn't have this buffer. Their crops relied purely on rainfall. No rain meant instant failure and exposed soil. Today, my research shows we are hiding behind an artificial buffer. That buffer is fading, and as it shrinks, the system beneath it is not getting any stronger or more resilient. It is becoming more fragile. The Ogallala isn't saving us. It is just making the eventual collapse into a dust bowl far more violent. In my field, an illusion of stability is more dangerous than chaos. It tricks us into ignoring the coming disaster. It lasts until the price of survival peaks and the crash happens. Part 12. The warmer baseline problem. Our records show the 1930s were hot, even compared to the old pre-industrial levels. But those numbers were nothing like today's peaks. I am looking at paleoclimate reconstructions that prove just how far we have moved. Historical data puts the global average back then at 0.1 to 0.3 degrees Celsius. By 2026, my sensors show we have hit 1.3 to 1.5 degrees above the baseline. That's a 5-fold increase. You and I need to understand that temperature controls the very physics of how drought works. Warmer air holds more vapor. It is basic thermodynamics. Warmer air creates a massive evaporative demand that sucks moisture right out of the ground. Practically speaking, even a small lack of rain becomes a total catastrophe when the atmospheric baseline is this warm. The rainfall that kept the soil alive in the 1930s is now being vaporized by the heat before it can help. It leaves the soil profile bone dry. We are seeing measurable drought symptoms appearing at an accelerated rate in our data. A drought doesn't need less rain to be worse. It just needs a hotter atmosphere to weaponize the existing conditions. We track this using the Palmer Drought Severity Index. It calculates how heat and rain deficits work together against the land. Let's look at this together. If we run historical rainfall shortages through today's temperatures, the results are exponentially more extreme. This is happening in an atmospheric state that is far more energized than anything seen in the 1930s. The same physical event now hits with more force. But I need to clarify a vital nuance in the data. I must be precise because the public often confuses this. Climate change is not the primary cause of these conditions. The real driver is an oceanic configuration, specifically a cool Pacific paired with a warm Atlantic. Our instruments show this pattern has appeared many times before, even when the planet was significantly cooler than it is today. We have tracked land degradation since the 1980s. It is driven by policy and economics, not just rising temperatures. The recipe for a dust bowl works without global warming, but climate change acts as a powerful atmospheric amplifier. It takes a standard oceanic drought and turns up the intensity. It makes a bad situation far more lethal. When land use leaves soil unprotected, the warmer air sucks the remaining moisture out at a much faster rate. My research identifies a self-sustaining feedback loop. The warmer baseline gives this loop the perfect environment to spiral out of control. The heat isn't the origin story. It is the amplifier that turns every variable in the disaster recipe up to 11. Part 13. Population in the dust zone. The original Dust Bowl forced 2.5 million people to flee. The Grapes of Wrath recorded that mass exodus of families moving west along Route 66. It was a human catastrophe, but our historical models show the landscape back then was largely empty and rural. The Great Plains of the 1930s was just small farm towns and isolated rural communities. The population density was extremely low, spread out across thousands of miles of open land. Today, the High Plains host massive urban centers. Lubbock, Texas alone has more than 260,000 residents. Amarillo has passed 200,000. Oklahoma City, right in the drought zone, holds over 600,000 people. These cities didn't exist in this form during the 1930s. Now, thousands depend on fragile grids and water systems. You and I must consider if they can withstand the coming storm. Our infrastructure wasn't stress-tested for an AQI of 1400, zero visibility, or the resulting mass collisions. Our intakes can't handle these fine silicates. This biological crisis scales with the population in a terrifyingly linear way. As more humans inhale this toxic atmospheric soup, we see a spike in respiratory failures and emergency arrivals. Productivity grinds to a halt, while long-term pulmonary degradation becomes a permanent biological signature. This systemic disruption, grounded flights, closed transport arteries, and shattered agricultural machinery, ripples through an infrastructure far more complex and fragile than in the 1930s. The psychological trauma of watching a city vanish into a wall of particulates is a non-trivial variable. We see the same atmospheric recipe, but the human footprint has expanded exponentially. The climate data is identical, but the consequence calculus has shifted to a lethal degree. Part 14. The Erosion of Data. April 14th, 1935. They called it Black Sunday. An atmospheric event of unprecedented scale tore across the southern plains. Visibility dropped to zero for hundreds of miles, launching thousands of tons of Earth's crust directly into the sky. Statistically, this event wasn't an outlier compared to the 3-year data trend for that region. The anomaly was its sheer intensity and its timing. It struck on a Sunday afternoon, catching the entire population fully exposed, well outside of their protective habitats or workplaces. The visual records of that day, monstrous walls of dust eclipsing buildings as people fled a brown apocalypse, became iconic signatures of catastrophe. The data shocked the nation, but stay with me, this matters more than the shock. The corrective feedback loop was incredibly tight. Within months of that event, the Soil Conservation Service was fully operational. By any bureaucratic standard, that is lightning speed. Hugh Hammond Bennett had modelled this erosion for years. The Dust Bowl simply validated his predictive data. As chief, he bypassed standard protocols, deploying every scientific and logistical tool at his disposal. The Great Plains Shelter Belt was active in 2 years. Simultaneously, conservation strategies were implemented to protect fragile zones, paying farmers to pull that vulnerable land out of production. Emergency geological surveys, erosion mapping, and educational programs were rapidly deployed across the entire regional impact zone. It was a fraction of our modern lead time. This rapid mobilization was driven by 2 key variables. First, the crisis was physically undeniable. Second, the policymakers of 1935 had observed the planetary decay firsthand. Their collective memory was still biologically intact. The administration's personnel had spent years directly monitoring the erosion of our topsoil reserves. Their understanding of the mechanics was elementary, but it was enough to isolate the failure points. And critically, the political will to intervene finally matched the terrifying scale of the problem. By 2026, that institutional memory is just ancient history. The original human observers who experienced the collapse are gone. The structural safeguards we once built, like the Soil Conservation Service, have been rebranded and reorganised for decades. Our core programs have been eroded by decades of budget cuts and bureaucratic restructuring. Political shifts have systematically reduced our operational reach. That decline in land conservation we analysed isn't a sudden reversal, but a predictable symptom of decay. It is a slow erosion of commitment, driven by competing budget priorities and a shift in agricultural economics. Worst of all, no one in the room remembers the original failure that built these systems. You and I can see it in the Environmental Working Group data. The spending trend is undeniable. Our prevention programs are systematically underfunded compared to those that compensate for loss. We have prioritised paying for the disaster rather than preventing the collapse. We've shifted from planetary defence to simple damage control. The irony here is that our scientific understanding of exactly how to prevent this has never been better. The 2009 data gave us a validated blueprint of exactly how our biosphere fails. Our data systems and satellite telemetry provide current officials with a real-time view of these conditions as they assemble on a global scale. We have the tools to identify the threat. What is missing is the institutional will to deploy them at a planetary scale. In my field, we call it collective memory. It is the shared knowledge and learned responses hard-coded into our institutions over time. The Soil Conservation Service was the primary carrier of that collective memory. It embodied every lesson learned at a staggering human cost during the 1930s. It hardwired those lessons into budgets and operations that kept the planet stable for decades. The progressive dismantling of that agency and its programs represents a dangerous form of institutional forgetting, a loss of systemic data. The raw data is still there, buried in archives. But the functional capacity to act at scale simply doesn't exist anymore, not like it did in 1950 or 1975. This gap between our knowledge and our ability to act isn't a historical accident. It is the calculated result of specific policy choices made across multiple administrations. And this is the central question you and I must face. The mystery isn't the disaster, it is our lack of response. Part 15. Insurance versus Prevention. The Federal Crop Insurance Program is one of our most durable and frankly alarming planetary policies today. In a typical cycle, the government covers 60% of the premiums farmers pay for this specialised federal crop insurance. Total federal outlays hit $8 to $10 billion annually. We see this program providing a financial safety net when yields plummet. When productivity drops below a threshold, the system covers losses from drought, flood, and other atmospheric perils we monitor from orbit. It is popular on the ground, politically shielded, and deeply woven into the very fabric of our rural farm economy. But our data suggests this structure is actually a primary driver of the land use patterns contributing to these disastrous conditions. Here is the anomaly. Most forms of crop insurance do not require soil conservation as a prerequisite for federal coverage. A farmer can plant on highly erodible land. These are specific zones our instruments flag as critically vulnerable to erosion. They receive subsidies without any commitment to erosion control. When the crop fails, the system simply issues a payout. The farmer gets paid, but the land remains exposed and defenseless against the next drought. The cycle repeats, endlessly. The Conservation Reserve Program, by contrast, pays farmers to let the land rest under protective grass or natural cover. This stabilises the soil structure, making it visible as a solid mass rather than airborne dust on our sensors. The payment is a simple rental rate. Whether a farmer enrolls depends entirely on the math of their expected returns. This includes the insurance backstop. Recently, for erodible land, that safety net has fundamentally warped the economic reality we observe. It is now more profitable to farm marginal southern plains land than to protect it. Our satellites confirm this isn't a secret. Economists and the Government Accountability Office have flagged this dynamic. Conservationists are sounding the alarm, yet the signals are ignored. Policy response remains stagnant. The result is a federal system that financially incentivizes dragging vulnerable land back into production for profit. We watch the system compensate the farmer when the land fails, while the planetary soil itself continues to degrade. Contrast this with the 1930s. Back then, the response wasn't just about cutting checks to cover a farmer's losses. It was about direct intervention on the ground. The Soil Conservation Service was doing more than just balancing books. They deployed technical staff to farms to demonstrate contour ploughing and plant shelter belts. They were physically rebuilding the land's defence systems. These plans kept fields from literally blowing away. Back then, the entire incentive structure was oriented toward prevention. Capital flowed toward actions that reduced vulnerability, not just paying for the damage after the atmosphere took its toll. This shift from prevention to insurance is a global trend. It is not something unique to the United States. It reflects a decades-long move toward market-based mechanisms, drifting away from the prescriptive land management we once prioritized. That shift has its defenders, but from our vantage point, the practical outcome in the southern plains is undeniable. The surface is more exposed than it should be, and the cost of that exposure is being socialized through insurance instead of preventing. We are socializing the cost rather than investing in conservation. The bill for the next Dust Bowl, it seems, is already partially open. How large will that bill grow before the math changes? That depends on a political decision we have yet to see. That decision remains unmade. It is the simple choice to speak the truth about what our sensors are showing us. Part 16. Why no one is calling this a Dust Bowl. Let's look at this central question from our orbital perspective. It deserves a serious look. The science is definitive. The atmospheric conditions are documented in our latest telemetry. Peer-reviewed literature explicitly makes the historical comparison. Yet, as of April 2026, no major federal agency has spoken. Not NASA, the USDA, the EPA, or the National Drought Mitigation Center. None have issued a formal statement using those two words. Dust Bowl. No senior official has stood before a camera to draw the direct line between our current era and the past. Not a single congressional hearing has asked if the conditions that triggered the original disaster have reassembled before our eyes. Why? The answer is more complex than a simple cover-up. The reality is far more fragmented than that. No single answer explains it. The first issue is the sheer institutional fragmentation within the government itself. The data for this story is scattered across multiple agencies, each with its own culture and reporting chain. NOAA monitors ocean temperatures. The USDA tracks agricultural losses. The EPA watches the deteriorating air quality. The NASA Earth Observatory provides satellite imagery, while the Natural Resources Conservation Service tracks erosion. Each agency sees its own data set clearly. They all see their piece of the puzzle, yet none of them has the mandate to assemble the full picture. No one is tasked with building the integrated narrative that Cook and his team published years ago. That was back in 2009. Today, each agency reports in isolation, never connecting to the planetary story. Without a central authority to synthesize this data, the formal warning of a new dust bowl remains a silent, unspoken ghost. We researchers have more freedom to interpret what the data truly means than any agency official. The second factor is simply economic and political risk management. Global commodity markets react sharply to how we frame our environmental findings. An official federal declaration of dust bowl conditions would crash land values and destabilize the entire agricultural lending system across the southern plains. That kind of announcement can trigger a market collapse, regardless of the actual physical state of the terrain. There is a fear that labeling this anomaly might actually accelerate the very feedback loops the term describes. Whether that justifies staying silent about such a massive risk is debatable, but it remains a critical variable in their calculus. The third factor involves legal liability and the unavoidable obligation to respond. If we admit the Dust Bowl is back, we have to admit our own federal programs and funding were contributing factors. At that point, there is an implicit mandate to act at a scale that matches the emergency. Calling this a Dust Bowl is not a neutral speech act. It forces a high-stakes mobilization for soil conservation, echoing the desperate atmospheric efforts we saw back in 1935 and 1936. This is costly, complex, and would require a total reversal of decades of planetary management policy. Then there is the disconnect between isolated events and the broader planetary systems we observe. Our news cycles focus on single events, a storm, a fire, a crash, rather than the slow shifts in the biosphere. This new Dust Bowl is not a single event. It is a fundamental change in the entire system state. We are looking at a convergence of variables that have locked into a truly catastrophic configuration. Those systemic shifts are far harder to communicate and act upon than a single dramatic event. A dust storm warning is a discrete event. The reassembly of the Dust Bowl recipe is a system state. Our human attention systems are wired to react to the flash, not the underlying decay. Taken together, this is not a conspiracy of silence or some secret suppression of our findings by bad actors. It is structural silence, the result of fragmented institutions and a deep-seated fear of responding to systemic risk. I'm talking about risks at the system level, rather than just temporary environmental shocks. The data is right there. We published the framework 16 years ago, yet the system refuses to respond at scale. People know. But our institutional architecture prevents knowledge from becoming action until the cost of inaction is absolute. That dangerous gap between our data and our actions is the real story. Understanding that gap is our first step. Part 17. Debunking the incorrect explanations. When official explanations fail to account for the alarming data, alternative, and often unscientific, theories begin to spread. I understand the impulse. Watching 260,000 people vanish into a wall of dust at midday is terrifying. Especially when the official response is just a drought monitor update and a quiet atmospheric warning. You search for a narrative that matches the massive scale of what you are observing. I get it. But here is the problem. A flawed hypothesis leads to a dangerous and ineffective response. When the real solution is already late, a wrong explanation is not just harmless, it is incredibly costly. Let's work through these explanations together. I am not dismissing the questions. They are legitimate, but we need better answers. The actual explanation already exists, documented and waiting in the peer-reviewed literature. That research points to real-world solutions we could deploy if we finally understood the true physics. Weather modification theories always resurface during anomalies. I want to give this a serious scientific answer, not a brush-off. Because the technical premise is real, atmospheric modification exists, and cloud seeding is a documented practice. Dozens of local agencies use silver iodide dispersal to force precipitation over our drying watersheds. The United Arab Emirates currently runs one of the most sophisticated cloud seeding programs on the planet. China has invested billions in this infrastructure. The tech is real, and the lack of transparency is concerning. That part is accurate, but here is where the theory breaks down, not on politics, but on physics. Consider the staggering energy scales required to generate the conditions we are observing across the southern plains. A 6-year drought pattern driven by specific, massive shifts in global ocean temperatures. Compared to the energy levels of any plausible atmospheric modification technology, the planetary systems we see differ by 10 to 12 orders of magnitude. I want you and I to grasp that figure properly. 1 order of magnitude is 10. 10 orders of magnitude is 10 billion times. 12 orders of magnitude is precisely 1 trillion times. Oceanic thermal anomalies are currently rewriting the entire atmospheric circulation of this planet. This thermal energy migrates across millions of miles of ocean surface, penetrating hundreds of meters deep for many years. The sheer energy involved here dwarfs every power plant and ionospheric heater our species has ever operated. This force exceeds every human-operated atmospheric intervention, combined by a scale that is frankly terrifying to visualize. This is no secret conspiracy or funding issue. It is a cold, hard problem of planetary physics. The ocean is merely responding to thermodynamic laws that govern this entire planet's systems. No technology currently held by any human actor can produce forcing on this massive scale. When someone claims this drought is manufactured, do not argue about politics or government intent. Simply demand an accounting of the energy budget. The raw numbers close this case. A second claim suggests we are merely seeing the typical variability of weather on the plains. This narrative frames it as a minor dry spell, hardly worth the alarm I am sharing today. This is contradicted not by one single metric, but by the convergence of every planetary dataset. Individual data points can easily be cherry-picked to support whatever conclusion you want to reach. 1 year of low rainfall is common. A single massive dust storm event is not impossible. A single season of agricultural land withdrawals is merely a policy story, not a planetary crisis. Taken alone, any of these individual data points could be rationalized within normal historical variability. What defies logic is all these variables appearing together, aligning perfectly with the recipe from 2009. That exact mechanism triggered the original Dust Bowl. Today, 6 years of drought and low conservation are colliding. We see record Atlantic heat, a shifting La Niña, and air quality events that shattered our measurement sensors. We are tracking massive dust storms in agricultural zones and continental transport from the original 1930s region. The probability that these variables aligned by random coincidence at this exact moment is not a matter of opinion. It is a statistical failure that cannot survive scrutiny. Each variable has only occurred in isolation before. The pattern they are forming together has a known name, a physical mechanism, and a certain outcome. Typical variability does not produce this alignment. The Dust Bowl recipe produces it, because that is exactly what we face. The third explanation is the most intriguing, because it looks in the right direction, but finds the wrong answer. The argument for climate change as the sole cause attributes every anomaly in the plains to global warming. This framing is not wrong about the role of climate change, but it overstates its primary influence. As I noted earlier, a warmer planetary baseline acts as an amplifier, making every feedback loop far more energetic. Climate change is real and measurable. It is making this current situation far worse than it was 50 years ago. However, climate change did not create the specific ocean configuration driving this drought. That pattern is a recurring historical event. These cycles will continue to occur on multi-year paths, regardless of what happens to global average temperatures. Climate change did not remove 11 million acres from conservation programs. That was purely a matter of agricultural policy. Climate change did not dismantle the shelter belt infrastructure from the 1930s. That was driven by mechanized farming economics. Climate change did not design the federal crop insurance program to incentivize planting on marginal, high-risk land. Those were legislative choices. The resulting land degradation that converts a drought into a dust bowl is the second ingredient. This is driven by specific, reversible human decisions that have nothing to do with atmospheric carbon concentrations. This distinction matters for our response. If climate change is the cause, the timeline is a 30-year project. It involves global coordination and massive infrastructure investments that are incredibly difficult for our species to achieve. That response is important for many reasons, but it will not protect a single acre of Texas topsoil this spring. If the Dust Bowl recipe is reassembling, we can interrupt it by restoring conservation land and reinforcing shelter belt infrastructure. By realigning crop insurance incentives toward conservation, the response timeline becomes a single farm bill cycle. The tools and programs exist. Our institutional capacity, however reduced it is, still exists today. The response is available now at a fraction of the cost. Getting the explanation wrong produces a dangerous misunderstanding. It forecloses the most actionable solution at exactly the moment when action is needed. The recipe is already known. The planetary ingredients are assembled. All that is missing is our collective willingness to acknowledge the data and react accordingly. Part 18. Can a planetary disaster repeat? On April 14, 1935, the Earth experienced what we now classify as Black Sunday. It was the peak of the Dust Bowl era and one of the most extreme surface-atmosphere anomalies in North American history. Before you and I analyse the telemetry of that day, we must understand the weeks leading up to the breach. The event lasted hours, but the structural instability of the biosphere had been compounding for several solar cycles. By April 1935, the High Plains sector had already suffered 5 years of severe hydrological deficits. The natural biological anchors of the soil were stripped across millions of acres, replaced first by failing wheat, then by a void. When crops failed, the topsoil became a loose, desiccated layer across a flat horizon, lacking root structures or moisture to hold the surface. The surface was, in an empirical physical sense, primed for atmospheric lift. It awaited a specific kinetic trigger. On April 14th, that vector arrived. An atmospheric surge began in the north, propelled by a violent cold front with surface gusts hitting 60 miles per hour. A particulate wall emerged, 800 miles wide and several miles high, hurtling across the terrain at 60 miles per hour. Survivors recorded a shifting geological cliff, a vertical, opaque wall stretching from the terrain to the upper atmosphere, advancing toward their position. Solar irradiance plummeted to zero within minutes. Midday was replaced by absolute lunar darkness. Not dim, total. Optical ranges fell to zero. Absolute zero. Human transport ceased as vehicles became useless in the opaque, particulate-heavy atmosphere. Pilots and drivers lost all visual reference points. Biological life in the fields succumbed to respiratory failure. Subjects in the open lost all spatial orientation, reduced to tactile navigation as they crawled through the dust toward safety. Dust breached every structural seal, every gap and every keyhole. Inhabitants deployed wet barriers against the infiltration, waiting in dark, oxygen-starved isolation. The spectral signature of the skies shifted to a deep, opaque void, an atmospheric extinction event captured in the data of survivors. This anomaly, which defied ordinary planetary experience, became the defining visual record of the entire Dust Bowl era. It remains our dominant image. Not the socio-economic fallout, but the planetary sky. Artist Woody Guthrie recorded the event from Pampa, Texas. He observed the encroaching particulate mass and composed a sonic record titled, "So Long, It Has Been Good to Know You." Federal observer Arthur Rothstein captured images of families fleeing the encroaching wall of dust, creating some of the most analysed records in history. Field observer Robert Geiger, travelling through the sector, transmitted a dispatch that provided the first formal classification of the region as a dust bowl. The event was not merely a weather spike, it defined a geological epoch. Analytically, the variables for Black Sunday are quite clear. One requires a vast expanse of unshielded, pulverized lithosphere generated by prolonged hydrological stress. Centuries of topsoil were compromised by aggressive mechanical disruption. You then need a massive frontal boundary to trigger high-velocity surface dynamics. You also require extreme desiccation in the atmospheric column directly above the launch site. These conditions prevent the mobilized particulates from being washed out by rainfall, allowing the mass to traverse hundreds of miles after a 6-week drought. Finally, you require a geographic source large enough to provide a high density of mobile material. There must be enough matter to fuel the storm's mass and maintain its structural integrity over vast transit distances. The eroded plains provided matter in volumes far exceeding the storm's requirements. The orbital mechanics of this disaster were straightforward. These variables merged into a lethal configuration, an assembly of data points we watched building for years before the collapse. Could these planetary conditions reassemble in 2026? You and I must look at this honestly, because both alarmism and denial carry costs. Exaggerate the risk, and you create a noise-to-signal ratio that masks genuine planetary threats. Minimize it, and you replicate the failure of foresight that devastated the population in 1935. Here is the precise, empirical answer. Not every variable for a repeat event has scaled to 1935 levels, and that delta is critical for our predictive models. Surface exposure in the southern high plains is currently increasing at a measurable, concerning rate. Yet the saturation of exposed Earth has not reached 1935 thresholds. Some vegetation remains, however degraded by 6 years of hydrological drought. It is severely compromised by over 1,100,000 acres of wildfire recorded in early 2026. This scorched biomass still offers a thin layer of planetary shielding. It is fragile. It is non-resilient. But marginal shielding affects the calculations. Furthermore, the atmospheric physics required for a Black Sunday event depend on precise frontal timing. This specific alignment of trajectory, velocity, and dryness is not a common seasonal occurrence in our atmospheric cycles. It synchronized only once during that decade. It demands a perfect convergence of synoptic patterns over the exact geographic coordinates. That specific atmospheric nexus is rare, even when the surface conditions are primed for a catastrophe. Look, you and I need to pass the data on rarity here, because our statistical reasoning is reaching a critical point. This is where human intuition fails us. Black Sunday was the outlier event of that entire atmospheric decade. Statistically, it was an outlier. It sat at the extreme edge of the distribution for those planetary conditions. Rarity does not mean unpredictability. It does not mean the physical variables required for the event were missing until impact. Those parameters were building for years. We just lacked the specific kinetic trigger, the exact cold front on the day. That front finally ignited the potential the landscape was storing. The event was rare, but the math worked. The vulnerability was common, it was pervasive, documented in our sensors, and yet completely ignored by the public. Our orbital data shows the distribution of outcomes across the plains has shifted in that same lethal direction. It shifted in the 1930s toward extreme volatility. The tail of that probability curve is getting much fatter. It is not that catastrophe is inevitable today, but the atmospheric background is becoming primed for it. 6 years of drought pushed soil moisture and surface cover toward the critical threshold for massive aerosol mobilization. 1 million acres of fire in 90 days stripped the land. Drought had already weakened the planetary surface. Withdrawals from conservation programs have returned fragile, erodable acres back into active industrial production. The spring frontal systems, generating those necessary wind events, will arrive on schedule as they always do. The atmosphere does not wait for our readiness. Scientifically, I cannot say Black Sunday will repeat this coming spring. The data does not support certainty, and speculation is irresponsible. But the components are fully assembled right now. The probability of a Class 5 event is measurably higher than it was 10 or 20 years ago. The hazard grows as these underlying variables develop. From my station, that is the statement risk assessment requires. It requires a shift toward outcomes that carry planetary consequences if the trigger is finally pulled. In one timeline, a researcher with drought data and soil surveys could have intervened in the 1930s. With vegetation maps and a grasp of synoptic meteorology, they could have modelled that fatal April of 1935. They could have warned that the probability of an extreme event was peaking. All the physical conditions were there. The trigger was a matter of when, not if. That data existed, but no warning matched the risk. On April 14, 1935, the trigger hit. Black Sunday proves that these extreme shifts are not impossible to anticipate. True anticipation means stating what the telemetry already shows before the atmosphere makes the point for us. It makes the point in a way that cannot be ignored and cannot be reversed. Part 19. The slow motion scenario. There is a version of this collapse that lacks a clear inflection point. There is no single date for historians to mark, no specific day the new Dust Bowl officially began, no iconic image of a dark wall swallowing a farmhouse, no single moment of shock for the world. Instead, we see a sequence, a slow, grinding, almost imperceptible accumulation of data losses and systemic failures. This compounds over the decades until the effects are indistinguishable from the chaos of the 1930s. It unfolds at a pace that never quite triggers the emergency response needed for a political pivot. This is what keeps us agricultural scientists and conservationists up at night, more than any single storm ever could. I must describe this carefully. Gradualism is not a comfort. It is the most dangerous variable in our model. Look at this trajectory from the ground. In 2026, the dust events are already becoming severe. Air quality index at 1400, haboob warnings, satellite plumes, and multi-vehicle crashes in near-zero visibility. This alarms those of us watching the data, but it falls short of an official national emergency. The drought monitor shows the same lethal colours as last year. Economic losses are high, but tolerable. Crop insurance handles it. The cycle moves on. By 2027, the losses have incrementally worsened. Conservation programme enrolment drops another few 100,000 acres. The systemic protective cover is vanishing. Shelter belts fail in Kansas. The Ogallala water table in the Texas Panhandle drops another foot. It drops 2 feet silently in the drilling logs. Only water contractors in quarterly reports see the drain. Eastern Colorado, which degraded a full category in a week in April 2026, simply never recovers. It stabilizes at the new low, then sinks. None of these alone cross the emergency threshold. No single photo moves the bureaucracy, but you and I can see it. Together, they represent a terminal trajectory. As you and I observe from orbit, the trajectory matters more than any isolated data point we collect. The real question is whether anyone with the power to alter this course is monitoring the signal closely enough before the damage becomes irreversible. This slow-motion decay follows a pattern we've seen before. It's not speculative, but a documented law of systemic and ecological collapse. It is a predictable sequence. It begins when output metrics drop, resource extraction costs spike, and the biological productivity of the land enters a terminal decline. Faced with sustained environmental stress, the immediate human response is always to double down, to intensify the extraction. They plant more land to offset the failing harvest, pushing their aging machinery past its design limits. They drain their capital reserves just to stay afloat, taking on massive debt against property values that haven't yet accounted for the ecological rot beneath. In desperation, they seed the most fragile, marginal sectors of the regional map, trusting that government insurance will pay out when the dust finally settles. When viewed at the local scale, this desperate gamble actually seems like a perfectly rational strategy. Any operator managing real-time variables and mounting costs would likely follow the same predictable path toward ruin. But at a planetary level, it's a disaster. Intensifying pressure on stressed soil doesn't fix the problem, it creates a lethal feedback loop. Those fragile sectors don't just fail to produce a harvest, they lose the final layer of vegetative shielding that was barely holding the planet together. The structural integrity of the soil dissolves. Within 2 seasons, the land is more damaged than if it had never been touched. An operation that seeds one extra marginal field to survive the season will soon find itself managing 2 degraded dead zones instead of 1. Economic pressure and ecological collapse are now perfectly synced, accelerating the entire system toward a hard reset. The humans act with logic, but the planetary landscape pays the ultimate price. Once intensification fails to balance the books, the only stage left is abandonment. And this is where our shared data starts to deviate from history. The deviation isn't in the final result, but in the mechanism and pace of the decay. Back in the 1930s, the collapse was fast and dramatic. Historical sensors captured the entire exodus, thousands of families fleeing ghost towns, leaving their lives behind in a visible, sudden rupture that permanently altered the social fabric. That disaster was a clear, sudden rupture, a massive shift that registered as a discrete event on the historical timeline. But today, the signal of abandonment is much harder to detect. It manifests as a quiet foreclosure in Amarillo, a red line on a spreadsheet after 3 years of failed crops and insurance payouts. Those payouts can't keep the system solvent because they ignore the underlying biological reality. The soil itself is dying, ensuring every future yield is lower than the last. We see an aging farmer left isolated in Deaf Smith County, his children long gone to the urban centres, with no one willing to purchase his land at any price. No drama, just a complete loss of energy. The system simply stops because there is no power left to keep it moving. It's the highly trained young specialist who returns home to take over, only to realise the fundamental variables of the land are already terminal. They run the simulations for 2 years before accepting the truth. The water is gone, the soil is dead, and the math no longer computes. So they choose the rational path of migration, seeking a habitat that isn't currently undergoing a phase shift into desert. Fallow land in a drought is simply an exposed target. The cause has changed, but the physical reality is the same. Miles of denuded, loose topsoil waiting for the wind to carry it away. Physics is indifferent to human timing. The wind doesn't care if the land was exposed in 1936 or by a bank notice in 2028. It finds the surface and begins its work. Human populations follow the same downward curve, just stretched across a much larger temporal scale. Because the decay is so widespread, it's difficult for those on the ground to see it as a single, unified event. This mass migration has been silently accelerating for decades, fueled by industrial farming and the slow death of the small town. It's part of a broader orbital shift toward urban centres that has defined human movement for nearly a century. This slow-motion disaster accelerates that trend past a terminal threshold, leaving the remaining communities unable to support even the most basic infrastructure. Across the plains, the critical nodes are failing. Hospitals are vanishing from the map as the population density bottoms out. Schools are shutting down due to a lack of human replenishment, and local economies are being erased by global digital shifts. All that's left is a skeletal structure of essential services, populated by those too old to begin a new life elsewhere. We see those who stayed because their roots were too deep to pull, trapped by love or a lack of options, watching their world die in real time. Once the economics of the land deteriorate past the point of survival, the last remaining residents lose the very foundation that kept their society upright. The critical logistics fail, the grain elevators go silent, and the equipment dealers close up shop because there is nothing left to process. The last doctor leaves, and as we watch, this entire world simply fades into the dust. These towns do not just vanish. From my perspective, they slowly decay, losing the ability to sustain human life with any dignity. Analysing the data over a decade, this planetary shift is the modern equivalent of the Great Migration. We are witnessing a mass displacement, driven by a lethal atmospheric combination of persistent drought and environmental neglect. Soil failure and economic collapse are forcing people out, just like the old migrations down Route 66. But this doesn't look the same. It doesn't produce iconic photos or protest songs. Instead, it generates a cold demographic statistic in a quiet census report. It is a data point in a regional survey, a chilling note about failing farm loans and local economic decay. The catastrophe is identical. Only the visibility has changed. My sensors do not need a Black Sunday event to register a disaster. No single dramatic moment is required. It only requires this current trajectory to continue for 15 years without any meaningful course correction. Every dataset we have analysed together points in that same direction. There is no deviation from this trajectory. The soil is shifting, water is vanishing, farms are failing, towns are emptying. Our protective infrastructure is crumbling. Each of these processes is individually, almost imperceptibly, gradual. Together, they form a vector pointing toward a fate the 1930s generation would instantly recognise. Even if this arrives without the black skies and dust walls that were impossible to ignore, the mystery is not what is happening. The real mystery is why our response lags so far behind the data we see coming. Part 20. The Unanswered Question. Let us return to the original point of departure. March 15th, 2026. Sensors in Lubbock, Texas recorded an air quality index of 1400. Forecasters in Amarillo issued haboob warnings over farmland that is not a desert and was never supposed to be. A massive highway crash occurred in zero visibility. My colleagues at NASA captured the dust plumes clearly from orbit. These plumes originated from the exact same source region as the storms of the 1930s. Amidst all of this, the federal government filed its quarterly loss reports without holding a single press conference using the term Dust Bowl. I want to pause and present an inventory of the evidence as plainly as I can for your consideration. Sometimes we must stop and read a complex body of evidence aloud, taking it all in as one breath. Listen so the cumulative weight becomes impossible to ignore. In a NOAA database, the Oceanic Nino Index revealed a terrifying thermal configuration. The specific ocean temperature signature, a cool tropical Pacific and warm North Atlantic, that scientists identified back in 2009. It is the primary ingredient for a dust bowl. Not a similar pattern, but a perfect chilling match. Enrollment records show 11 million fewer protected acres than our peak in 2007. The soil is exposed. This fragile, erosion-prone land once had protective cover. Now that defensive layer has vanished from our maps. The Drought Monitor shows nearly all of Texas and Oklahoma in crisis. The data is pulsing red with drought. This episode already exceeds the duration of the drought before Black Sunday. We have moved past the historical comparison point. We have entered the territory that history warned us about. Wildfire statistics show over 1 million acres burned across the southern plains in just the first quarter of 2026. This incinerated the remaining cover on land that 6 years of drought had pushed to the absolute edge. Air quality records show a major city hitting 3 times the level our agencies classify as hazardous. This was off the charts. Forecasters were suddenly using the vocabulary of Saharan desert meteorology to describe American soil. Every data point is available in a public federal database. These findings are not hidden from anyone. No special clearance is required. You do not need insider access to see what I see. The data is sitting there, waiting for someone to assemble the pieces into a terrifying whole. Peer-reviewed literature from 16 years ago already described this exact mechanism with chilling scientific precision. The recipe was recorded, every feedback loop was quantified, every threshold was identified in the data. Those researchers published their findings because understanding the science was the only way to prevent a total recurrence. They gave us the answer to a question we had not even finished asking. Then, 16 years slipped away. We have the understanding, we have the orbital data. Our satellites, monitoring systems, and drought maps are all operational. We even have the policy tools. The Conservation Reserve Programme exists. Shelter belt infrastructure is there. Every program we need is already in place. Our sensors show the conservation network is real. It is not just a theoretical model. These programs are fully operational, with teams on the ground and deep ties to the farming communities. But the resources are drying up. Funding is dropping even while the environmental threat grows more intense and dangerous. The architecture for a massive scale-up is ready. The scaffolding exists. We just need the command to build. As of April 2026, we lack a single official with the courage to stand before a camera and speak the truth. They refuse to say what our data has been composing for 6 years. The same Dust Bowl conditions have returned. Our peer-reviewed science identified this 16 years ago. The government response must finally match the scale of the disaster. That warning remains unsaid. I have searched the archives. It is missing, and that silence is the most significant fact. You and I should wonder what the survivors of the 1930s would think of our current silence. This comparison is hard for me to stomach, and it should be for you too. Those who survived the first Dust Bowl did not have our modern atmospheric studies or planetary data. They lacked the ocean buoys that feed real-time temperature data into our public climate indices. They lacked the NASA Eyes in the Sky to track dust storms, or our weekly national drought maps. They lacked the planetary models capable of isolating the variables behind these massive and terrifying atmospheric shifts. They had no advanced sensors, only neighbours dying from dust pneumonia. I see records of children in rural hospitals with lungs choked by sharp silica particles. I see farmers standing on their porches watching the topsoil blow east while wondering if they could even afford to buy food. They watched the sky turn black at noon on a Sunday. Within months, they had launched the Soil Conservation Service. They planted 220 million trees and immediately deployed emergency conservation tillage practices across the vast plains. They passed the laws and moved the resources to protect the soil. They actually acted. They moved with incredible speed and scale because the disaster was undeniable and right in their own faces. In 1935, the leaders had the courage to meet the crisis with overwhelming force. We have the technology they lacked. Our early warning systems are online and watching right now. We have decoded the mechanism before the catastrophe hits. We track every variable in real time. History is not just trauma to us. It is documented, modelled, and peer-reviewed planetary data. In every technical sense, we are in a much stronger position than they ever were. Yet our response is tiny. We have done almost nothing at the scale this disaster demands. We produce charts and reports and quarterly updates, while the programme budgets slowly vanish. We have documented the coming collapse without moving to stop it. There is a very specific word for this gap. In human psychology, We call it denial. But denial might be too simple. In our massive institutional systems, the failure has colder, more bureaucratic names. These names are actually worse because they are structural. We call it bureaucratic inertia. Large systems keep drifting because changing our planetary flight path requires far too much energy. We are rewarding failure. Our policies pay for losses instead of preventing the damage. It prioritizes insurance payouts over conservation investment. It makes destroying fragile land the only logical and financial choice for survival. Risk aversion means leaders fear that saying Dust Bowl out loud will cost them too much, until the silence breaks. Then there is the issue of fragmented accountability. Every agency sees its own specific data clearly, but no one is authorized to save the entire planet. You and I don't need villains or conspiracies for this. The data isn't being hidden. These are just the mechanics of large systems failing to react to slow, massive planetary risks. It is like an institution ignoring a growing tumour because it has not killed them yet. If this happened overnight, we would be in emergency mode. But because it is slow, they wait for one more budget cycle and one more year. From my orbit over the southern plains, the view in 2026 is terrifyingly clear. Let us be clear. They might claim uncertainty as an excuse, but on a planetary scale, there is zero ambiguity. My colleagues and I see the data telemetry clearly. No serious planetary scientist disputes what these readings signal. Our peer-reviewed models on these dust events aren't guesses. We have 16 years of satellite data verifying this atmospheric mechanism. The terraforming tools we need aren't new tech. We are looking at the same survival protocols deployed after the first crisis. Those systems proved effective back then. Now, as I scan the planet from above, only one variable remains a total anomaly. It isn't a degradation of the southern plains. From orbit, we have documented and measured every millimetre of that decay. The real mystery is the silence below. The original collapse claimed 7,000 lives through respiratory failure and widespread starvation. It triggered a massive human migration visible from space, forcing 2.5 million people to abandon their parched homes. 100 million acres of life support destroyed. Much of that terrain has never recovered its baseline biological productivity. And all this catastrophic damage occurred even though the orbital warning signs were flashing red for years before the impact. Visible to the sensors, to the lab technicians, and to anyone standing on the ground in 1933. By 1934, the planetary scans were undeniable. The disaster wasn't a hidden variable. It was an ignored warning in our files. The people who ignored the telemetry weren't acting out of malice. They simply lived within a system that couldn't translate warnings into action. Now we have high-resolution imaging and zero excuses. You and I are left with a question that has no answer yet. The outcome is being scripted in real time by the choices being made, or ignored, inside the halls of Washington. It depends on budget talks and whether we fund the protection of vulnerable land or let the ecosystem continue its decline. It depends on farm legislation and whether we pivot our planetary incentives toward conservation or maintain the failing status quo. By operators in the Texas Panhandle and Oklahoma making planting decisions as the spring mission begins. On terrain left fragile by 6 years of drought, while massive weather systems gather strength across the Pacific and Atlantic. They are forming the exact atmospheric configuration that our researchers identified 16 years ago as the trigger for a catastrophe. This storm is no metaphor. The physics are not theoretical. This silence is not an accident. Beneath a sky that pushes our instruments to their limits, on soil parched by 6 consecutive years of moisture loss, the southern plains waits to see what kind of planetary narrative this turns out to be. A story of warnings heeded or one of warnings ignored. Back in the 1930s, those people never got to choose their narrative. You and I still do. But that window, like the topsoil itself, will not stay open forever.